out for page 14. Going to talk about tangent graph. Okay, so the graph here is a tangent graph. Okay, if you can see, this line is the y-axis, and this line is the x-axis. Okay, just make it clear. The graph can keep going. Okay, we'll keep going. So this one is asymptotes. Okay. These ones are asymptotes. Then we have asymptotes here as well, and asymptotes here. Okay. Can anyone tell me what you have observed from this graph? Okay, just ignore everything what you can see. Okay, what are the special key features you can see from this graph? Yeah, Sarah?
Repeat itself.
Yeah, repeat itself. What's the after how long? Like we can say that's a period if you repeat yourself, right? The sign repeats the same graph after 2 pi. How long it will repeat itself? Yes? Yeah? No? Sorry, what is it? Pi. Okay, this asymptote is negative pi on 2. This is pi on 2. So what we can see is the distance in between any two adjacent asymptotes, they are the same. Okay, the distance between any two adjacent asymptotes is the same. Like distance is the same, pi, 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 and you repeat again. Okay, so what we can see, the period for tangent x, okay, just pure tangent x, the period equals to pi. Okay, the period equals to pi. Okay, another question is why this graph has asymptotes? Why there are asymptotes? Why sine, cosine we don't have asymptotes? Why tangent we have asymptotes? Yeah, what is undefined? What value make? Yeah, Sarah?
Wait, what was your question?
Why there's asymptotes?
Why they are, alright,
Yeah,
yes.
why there are asymptotes?
Well, I was gonna say because there were some undefined values, but then you were like,
Yeah.
what is undefined?
Yeah, what's the undefined values?
They're like 2 over 0 or something when you have like a number that goes 0 to 9.
Yeah, that's correct. So tangent is sine x over cosine x. When your denominator, when the x value make the denominator become 0, then the graph become undefined, and the undefined value will be pi on 2. Okay, this one is 3 pi on 2. You know, like when we do the unit circle, if you go back, you don't need to go back, I'll just show you the table. For this table, see the two undefined value, pi on 2 is undefined, 3 pi on 2 will be undefined as well because the cosine pi on 2 is 0 and the cosine 3 pi on 2 is 0, so those two values will give you a denominator 0, therefore is undefined for tangent. Okay, if you think about this,
So why does the tangent have to be undefined?
Sorry, what's your question?
Assumption.
Because tangent is sine over cos.
Yeah.
Denominator can't be 0. If denominator is 0, then tan will be undefined. Like for example, 1 over 0 is what?
I get it.
Yeah, 1 over 0 is undefined. So sine divided by cos. So when basically we can say when cos x equals to 0 is undefined. And if we think about the unit circle, cosine x equals to 0 at this place and at that place, right? Like here and here will give cosine equals to 0 because it's 0, 1, 0, negative 1. Okay, so if I think about in like positive, this angle will be pi on 2. But if I think about negative, this angle will be negative pi on 2. That's why we have this one. But this angle can also be 3 pi on 2 if we count it from the right, like the anti-clockwise. That can be 3 pi on 2 as well. So that's why we have this angle here. And we can keep having zeros, like when we add another 2 pi, we subtract another 2 pi. So we can have all the values on left-hand side and right-hand side. That's the asymptotes. Okay, what else do you have noticed? That's correct. All you said is correct. There's another thing, like a key feature for the graph. Okay, asymptotes is a key feature. What else can be key features? Point of inflection. Okay, where is the point of inflection? In the middle. Good, in the middle. On the x-axis and in the middle of the two asymptotes. So it's right in the middle for this asymptotes, point of inflection. Okay, there's one at 0, 0 as well. Okay, that's all the things we can see. Let's have a look at the paragraph. And like, again, this equation looks like this. Okay, it exactly looks the same as the sine and cosine. We just change the sine cosine into tan. So we have A tangent x minus epsilon plus c. Okay, so what we can observe from this is the complex form of the tangent, the most complex form. So the tangent x looks like this. And after we do the transformation, like A is the dilation, N is dilation, epsilon is the horizontal movement, and the c is moving up and down. Okay, first of all, there's no amplitude for this graph, which means the ranges are. Like amplitude is in between, middle, like how much I can move up, how much I can move down. There's no such things. It's just negative infinity to positive infinity. That's range R. And this graph has asymptotes, and that's what you noticed already. The distance between the adjacent asymptotes is equal, right? It must be equal, like the repeating, like it's the period. Okay, so the period of tangent is different. The period for sine and cosine is 2 pi, but the period for tangent is pi. And therefore, after the dilation, the period will be pi on n instead of 2 pi on n. Okay, for sine and cosine, the period is 2 pi on n, but for tangent, the period is only pi on n. And also, there will be point of inflections occurs halfway between the asymptotes. Okay, occurs halfway between the asymptotes. Okay, let's think about this. If I can find any two adjacent asymptotes on the graph, I can find everything else, right? I know two asymptotes, I know the other two, I know the other two, same distance, here, 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 here. And then point of inflection occur halfway, 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 so I know exactly where they are. So the most important thing, there's only one important thing for tangent graph, is find two asymptotes. Okay, that's the only thing. So let's have a look at this. How do we sketch this graph? So first of all, we label the mean line of y equals to c. Instead of saying there's a mean line, okay, instead of saying that's a mean line, we can say that's where your stationary point of inflection exists. Okay, that's where your stationary point of inflection exists, so the point turning. So let's have a look at example 1. Example 1 asks us to sketch 5 tangent 2x plus 1. So the 1, let's sketch the 1. Okay, that's where is the stationary point of inflection. Well, same, you don't need to draw it, but like when you draw it, that's fine. Okay, next thing is, what I will do next is I will make 2x equals to pi on 2, and I will make 2x equals to negative pi on 2.
Wait, what?
Okay, I will explain why. Not finished. Why are we doing this? Okay, I'm trying to find asymptotes. Okay, if the angle equals to pi on 2 is undefined, right? Okay, tangent pi on 2 is undefined, agree?
Yes.
Tangent negative pi on 2 is undefined, agree?
Yes.
Okay, and they are adjacent values. Like, if you think about, we have negative pi on 2, and the next value undefined will be pi on 2, if you think about anti-clockwise. Okay, so if negative pi on 2 is the first undefined value, the next one will be pi on 2, right? And then the next one will be 3 pi on 2. And then you just keep going. So I find two adjacent values, negative pi on 2 and pi on 2. You can find other things, pi on 2, 3 pi on 2, that's fine. But those two are obviously much easier to calculate. I just choose two values, same as when I make the sine bracket equals to pi on 2, make the cosine equals to 0, trying to find maximum point or minimum point. Well, that's not the only point give you sine equals to 1. I can make other points equals to 1 as well, but it's just easy to do calculations. I choose two smaller values and adjacent values Okay, it's easy to do calculation, but they must be adjacent. I can choose pound 2 and negative pound 2, or I can choose pound 2 and 3 pound 2, but I can't choose negative pound 2 and 3 pound 2. They are not adjacent values to make it undefined. So that's why I picked those two. I will solve for that. I got pi on 4, and this equals to negative pi on 4. Those two values are the asymptotes, because that's the x value make the function undefined.
So does that mean these are the asymptotes for every single tangent graph?
No, x equals to pound 2 and negative pound 2 is the asymptotes. But the angle equals to pound 2 and negative pound 2 will be correct for all the values you do, like all the tangent graph you're doing. Because doesn't matter what's the bracket. If you replace the bracket by pound 2, that's undefined.
Okay.
Yeah?
And how do you know the values are adjacent? Like you said negative.
Well, like, think about the position. There are only those two positions. If you start with negative pound 2, well, the next one must be pound 2. And the next one is 3 pound 2. And the next one is that. Like, you just keep turning. And what's the next value you can reach? Or if you don't like to go anti-clockwise, you can go clockwise. Well, the next one is negative 3 pound 2. You can use those two values as well.
But
Yeah.
to find out like the adjacent asymptotes, wouldn't you divide the period first?
No, because doesn't matter what you have. What's the period? Doesn't matter. If you replace the bracket become pound 2, it's undefined. Whatever the period is, like it's always undefined. Yes? If you replace the bracket by negative pound 2, it will be undefined. Doesn't matter whatever you have. It's just like x equals to pound 2 and minus pound 4 will definitely make this graph undefined. I just want to find two undefined value. After I find 2, I can find all the rest, and the period is given already now. Because think about these two asymptotes. What we have, the asymptotes will be here. Okay, according to what I'm doing, is here x equals to minus pound 4, and here x equals to pound 4. Okay, what's the period? What's the period? Pi over 2. Okay, the distance between the two adjacent asymptotes, it is pound 2. And if you calculate by using the formula, period equals to pound 2, no problem. Yes, that's just that. And then because you have worked out what's the period, so the next asymptotes must have the same distance. So we have it here. X equals to 3 pi on 4, I think. And I can also go left hand side. There's another one. It's a negative 3 pi over 4. Okay, and I have reached my domain, I think. Yeah, the domain is negative 3 pi over 4 and 2, 3 pi over 4. So I've reached the domain. That's the 4 asymptotes we have for this graph.
And then you just draw the tangent graph.
Yeah, like not yet, but like almost. Because I have labeled all the asymptotes within the domain. And the next thing is we label where is the point of inflection. So all the point of inflection will be in the middle. So it will be here, here, and here. Okay, they are the point of inflection. Okay. If you think about the shape of this graph, okay, not 3 of that. If you just think about 1 of this, okay, within 1 period, what's this graph looks like? Like which graph we have drawn? Cubic. Yeah, cubic. Or like any polynomial graph, like it's most like to a cubic graph because it's like this shape or the other shape. Okay, when we sketch cubic graph, there's increase in cubic and decrease in cubic. Do you remember that? Like we have this way or the other way. Same as tangent graph, there's 2 ways as well. We can have everything with this shape or the other shape. So what decide that is, okay, like cross the number 5. I think I forgot something in number 5. Okay, just cross that out. We rewrite this. If A and N are both positive, or negative, then increasing graph. If A and N is if A and N are one positive, one negative, doesn't matter which one positive, which one negative, then decreasing graph. It's kind of the same as the cubic graph.
You mean
Like A is negative 2, A is 3, one negative, one positive. Is one negative value, one positive value. And what affecting period? Is a value. Like for example, in this case, N is 2. A is 5. Well, what basically I want to say is, if and they're both positive numbers, like 3 and 5, or both negative, like A is negative 2, A is negative 4, or one positive, one negative, then they are increasing. But if like A is negative 4, A is 5, is one positive, one negative, then this graph is decreasing. Yeah, that's what I want to say now. So, well, do we have a positive graph or negative graph then? Positive. They're both positive. So we have a positive graph. We can sketch that. Okay, that's 0.2, 1, that's 0, 1, that's negative 0.2, 1. And you need to label the 4 asymptotes as well. Yeah, that's the shape. Yeah, that's it. It's easy then.
So you don't have to label any other points?
No, I have another graph. Next page.
So you don't have to label any other points?
You should label x-intercept, but this x-intercept we haven't learned how to label, how to work out that. Like we will go back to this later.
Does that mean you don't need to add like label any extra points?
Well, you need to label x, y intercept. That's always. But in this question, the x-intercept we haven't learned how to solve tangent function yet, and also the value they are not really exact values when you solve x-intercept. So we'll come back to this point later. Next week. Okay, so what I will ask you to do now is use the same method to sketch this one by yourself. When you finish, that's the end of the lesson. Well, I will show you the answers later. Just try to sketch that one, but use the same method. Okay, so what we have here is y equals to 3 is the negative 3 is the middle line, so I draw a horizontal line here, and I always make whatever in the bracket equals to pi/2 and negative pi/2, and I'll solve for the x. I'll solve out x equals to 1 and x equals to negative 1. That's the two asymptotes here. And I sketch x equals to negative 3 as well. Okay, and the point of, well, there should be another one. There should be another one at 3. But I don't have the domain for 3. I have the domain up to 2. So, well, you know, in between 1 and 3, the middle will be 2. So 2 is just the point of inflection. Okay, 2 is just your point of inflection. And 0 is the point of inflection, and negative 2 is the point of inflection. Well, I see a lot, well, it's a decreasing graph as well, because A is negative 3 and N is pi/2, so it's a decreasing shape. we have decreasing shape, but I think some of you may tell me like your graph is not accurate because it's not approaching to the asymptotes. I know that, but like because the scale for this graph is not very good, and when you solve for x-intercept, actually the x-intercept should exist there. Okay, should exist where I sketch it. That's why my graph cannot approach into asymptotes, and also you don't know how to find x-intercept yet. So your graph is fine. Like you are, I think a lot of yours approaching to the asymptotes actually, but my one can't. Unless if I extend that really, really long, then it will approach.
We were meant to find the x-intercept.
We'll do that next lesson, which is Thursday next week. We'll do that. But you can't do it now. Okay, you can't do it now. So that's what the graph should looks like. I should have 3 asymptotes at -3, -1, 1, and 3-point reflection, -2, 0, and 2, which 2 is also the endpoint. You can't sketch any graph beyond that. Okay, any questions? No? Good. Done for today.